AIDS. For decades, that word alone carried this incredible weight of fear and, honestly, a lot of misunderstanding. But today, our scientific understanding has completely transformed the conversation. So what's actually happening inside the body when HIV leads to AIDS? Let's dive into the microscopic battle that unfolds. It all really starts back in 1981. The first cases were reported in the US, and it just sparked this widespread panic. The 80s, that was a really dark time, filled with stigma and so much misinformation. But what began as this terrifying mystery has now, thanks to some incredible scientific effort, been turned into a manageable medical condition. And that history is so important, but it brings us to the real core of what we're talking about today. What is the virus doing? How does it so systematically take apart our body's defenses? To get that, we've got to go inside. So, here's our plan. We'll start by making sure we're all on the same page with the terms. Then we'll witness the body's battle against this virus. We'll see what happens when those defenses finally fall. We'll cover the medical revolution that changed absolutely everything. And then we'll look at what the path to a cure might look like. Okay, first things first. It is absolutely crucial that we understand the difference between two terms that people often and understandably use interchangeably: HIV and AIDS. They mean two very, very different things. Here's the bottom line. HIV is the virus. It's the microscopic invader. AIDS, on the other hand, is the condition. It's the whole set of symptoms that can show up years later, but only if an HIV infection goes untreated. You simply can't get AIDS without first being infected with HIV. One is the cause, the other is the potential consequence, which thankfully is now avoidable. And make no mistake, this is not just some piece of medical history. As of 2022, there are an estimated 39 million people living with HIV around the world. It is still a major global health challenge, which makes understanding how it works more important than ever. All right, now for the main event, the microscopic war that kicks off the second HIV gets into the bloodstream. It's really a story of cellular espionage, a brilliant and kind of sinister hijacking of our own biology. So HIV has a very specific target. It goes after a type of white blood cell called the CD4+ T cell. The easiest way to think about these cells is as the generals or the commanders of your immune system. They're the ones calling the shots, identifying threats, and coordinating the entire defense. And by targeting the commanders, HIV's strategy is to take down the whole army. So how does this hijack even happen? Well, first, the virus infects one of those T cells. Then it does something really clever. It uses a special enzyme to rewrite its own genetic code from RNA into DNA, basically translating it into our cell's native language. Next, it actually stitches that viral DNA right into the cell's own chromosome. And that leads to the sneakiest phase of all, latency, where the virus just goes. And this right here is what makes the whole process so insidious. The virus's genetic code literally becomes a part of you, hiding in plain sight inside your own DNA. Your immune system can't spot it because it's completely dormant. So for years, a person can feel perfectly fine, all while the virus is quietly setting up shop, getting ready for its final attack. After that long, quiet period, and we're talking sometimes for years, the battle enters its final, decisive phase. This is the moment the immune system starts to collapse, and that marks the transition from being HIV positive to developing AIDS. This chart shows that turning point perfectly. As the hidden virus finally activates and starts making copies of itself, it destroys the T cells it was hiding in. You can see the CD4 count, our immune commanders, just plummets. At the exact same time, the amount of virus in the blood, the viral load, goes through the roof. It's this inverse relationship that signals a total system failure. And with its commanders gone, the body is left defenseless. It becomes wide open to what are called opportunistic infections. These are illnesses that a healthy immune system would normally swat away without a problem, like rare types of pneumonia. Cancers like malignant lymphomas can take hold, and severe neurological problems can develop. This systemic collapse is what defines AIDS. Now, that sounds incredibly bleak, and for a long time, it really was. But, and this is a huge but, that is not where this story ends. A medical revolution completely flipped the script for people living with HIV. Here's the most important thing to remember. That whole devastating scenario we just walked through, that's what happens to an untreated HIV infection. Today, that outcome is no longer a given. In fact, for anyone with access to modern medicine, it's actually preventable.
The big breakthrough was something called multi-drug therapy, or antiretroviral therapy, ART for short. The name comes from its ability to fight a retrovirus, one that cleverly works backward from RNA to DNA. Instead of using just one drug that the virus could easily learn to resist, ART uses a cocktail of drugs that attack the virus from multiple angles, stopping it from ever making copies of itself. And you really can't overstate the impact of this. With consistent treatment, the virus gets suppressed to a point where it's literally undetectable in the blood. This means the immune system has a chance to recover, and the person can live a long, healthy life. It has transformed AIDS from what was almost a certain death sentence into a manageable, chronic condition, a lot like diabetes.
So, learning to manage a virus like this is a monumental achievement. But can we actually take it one step further? Can we get rid of it entirely? Well, this final part of our journey looks at the incredible science that's pointing towards a real cure. Some of the biggest clues might be coming from this extremely rare group of people known as elite controllers. These are individuals who are HIV positive, but for some amazing reason, their bodies just naturally keep the virus suppressed without any medicine at all. They never get sick. And for years, scientists have been studying them, trying to figure out their secret. And now, we think we know the answer. It turns out that in these elite controllers, when the virus inserts its DNA into their chromosomes, it almost always ends up in these non-functional areas, what some people call junk DNA. And because the viral code gets stuck in a silent part of the chromosome, it can't be turned on to make new viruses. It's basically locked away in a genetic prison forever. Understanding this mechanism, that is a massive step forward. For decades, medicine has let us coexist with HIV to keep it at bay. But the secrets hidden in the DNA of elite controllers, well, they suggest a whole new possibility. The question is no longer just about how to suppress the virus, but about how to copy this natural defense and find a real cure. We've learned to coexist with it. The next great challenge is to finally win.